Again, we would like to express our gratefulness to the wonderful opportunity to share our experience in the smart building application for sustainable performance in building life cycle. We also would like to introduce ourselves. My name is Dian Fitria, a lecturer in Architecture Study Program of Multimedia Nusantara University. And this is my colleague, Ibu Ika Putri Dermawan. She is a green building verifier in PT Sertifikasi Bangunan Hijau. To shorten the time, let's directly hear from Ibu Ika about smart building and its positioning in sustainable building in general and lighting system design for office buildings specifically.
Smart building design around its service for the user, how it responds to the internal and external environment, and integrating building system for optimization and detecting any malfunction. Smart building as a supporting part of green building, healthy building, and net zero building provide better control, monitoring, and integration as supporting systems such as lighting and daylighting. Next. The paper purpose is to know how critical smart design through integrated approach in sustainable performance in building life cycle. Focus in smart lighting design in office building. The research method is using qualitative method with a case study approach. The data consisted of simulation, calculation, drawing, and material specification that's collected during the design process.
We can see from its mass and orientation that already respond to the climate by having the longer facade on north-south orientation. So its basic building design already accommodate the needs to reduce solar heat gain by optimizing orientation and avoiding glare from direct solar at one time. The next step is passive design approach. Through the architectural design, the team tried to maximize the daylight penetration in the building by considering well-being and energy efficiency. The optimization was conducted by the window-to-wall ratio optimization and glass selection. As you can see, the window-to-wall ratio value reached up to 68% that accommodate the need of visual connectivity between indoor and outdoor. In addition, the glass specification was chosen is with the higher lighting transmission value, which is 40%, and lower heat transmission value with U value 1.61 and shading coefficient value 0.28. Of course, this optimization cannot be detached from the simulation and calculation behind. We conduct simulation for daylighting and conduct calculation for OTTV. The result was up to 50% occupied area can be covered by daylight for the whole working hours. For the OTTV, the result was 32.8 watt per meter square, which is below from national standard Indonesia, which is 35 watt per meter square. Furthermore, as an active design approach, the result of isoline with 300 lux in daylight simulation can lead us to determine grouping the luminaires installation. The grouping of the luminaires we divided into two zones. First, zone with daylight coverage at the whole working hours, or we can call it as daylight area with 70 luminaires. And the second, zone with partial daylight coverage in particular working hours, or we can call it as non-daylight area with 84 luminaires. For sure, we also managed to use energy efficient luminaires, which is LED with color rendering index above 80 and no mercury content. Finally, the installation of smart building feature can be done by incorporate look sensor that connected to building automation system. The scheme work of the automation is once the sensor receives daylight on 1000 or lux or above, the lighting will be turned off. Once the sensor receives daylight below 1000 lux, the lighting will be turned on. At the conclusion, we saw that efficiency in lighting can be divided into two types. First is direct efficiency from lighting load, and the second indirect efficiency from cooling load that caused by the reduction of sensible heat from lighting. We also agree that smart design helps the installation of smart building feature will be more effective to deliver performance in energy efficiency. And we also consider that smart design needs the collaborative roles by multidiscipline parties, at least between architect and electrical engineer at this case study.
As a recommendation, in order to deliver well-being, the smart building feature can be added with automatic blind. Hopefully, our experience in this case study will give benefit to all of you in pursuing sustainable built environment through smart building application. Thank
Thank
you.
you.